Hey there, everyone. Welcome back to comp102. This is lecture 11, and today we step into the word compound data types. So far, we have seen scalar types, an integer, a float, a Boolean value. Each holds a single value. We have also seen one compound type already. That's a string. A string is basically a sequence of characters. Now we want something more general. We want indexed sequence of elements, and those elements can themselves be compound structures. So Python gives us about two main options. The first one is something called a tuple. Tuples, which are immutable. Once you create them, you cannot change them. And lists, these are mutable. You can change them freely. A tuple is an indexable ordered sequence of objects. And the objects inside, they can be of any type. They can be integers, they can be strings, even other tuples. So tuples can contain other tuples also. Here, the key thing is that the tuples are absolutely immutable. So that means once you create a tuple, you cannot change its contents or its elements. So think of a tuple like a WhatsApp message that you have already sent. You can leave it, you can regret it, but you cannot edit it. Let's take a look at tuples in this code. We have created one with the parentheses, as you can see in this line. T equals open parentheses, and then we put an integer 10 here, and then a character, a string A, and then it is floating point 7.5. So as you can see that we have put many different types of values in this single tuple, and there are 4 values in this case. So this diagram shows each element in a box, and so basically these numbers underneath these values, they're the positions of these items as in the string characters. They go through 0 to 3, but they also have negative indices. Calling length of t, in this case, that is going to give you the length of the tuple, and in this case, it's going to give us 4. And just like strings, you can also use negative indices. So t minus 1 is going to give you the last value that's at the end of the tuple. And what if you try t at an index 0 and you try to assign some value? Let's say instead of this 10, you want to replace it with 5. You'll obviously get an error. And just like strings, the tuples are immutable. There are no changes allowed there. Here's where tuples become really useful. Look at this function, get stats. It computes total, count, and average. The return statement basically says return an open parentheses and then total, count, and average, all comma separated values. So if you look closely in this line, this is creating a tuple, and it's returning exactly one object, and that is this tuple. But again, this tuple holds 3 values. So you can grab the whole thing, and the results basically equals whatever this function is returning, and that's the tuple. So this result is going to be a tuple of 3 values. So now the cool part, you can unpack the tuple. So if we print the result, you can see that it's printing the values. Now here in this line, there's an example of unpacking. So we write SCA, and that equals to this function call. And now each variable is going to hold one piece. So what's happening is it's returning a single value, and then that single value is being decomposed into these 3 variables, S, C, and A. And when you print these variables individually, so these act as separate variables and with the values that were elements of the tuple. So it's like ordering a deal at KFC. One box comes out, but inside you've got a burger and the fries and the drinks. Unpacking it, just opening the box and putting the stuff out of the box and onto the table. All right, so here's the big takeaway. By returning one object, a tuple, you can effectively return multiple values. This is a pattern that you'll use all the time. Whether a function needs to give back more than one piece of information at a time, if that's the case, then you just pack all the values in the tuple and return that. All right, so this is your turn. Here's a function called character counts. So basically, it takes a string of lowercase characters and it returns a tuple. The first element, that's going to be the number of words, number of vowels, and the second element is going to be the number of consonants in this string that's being passed as a parameter. So pause the video, try it out. You'll need a loop and a way to check if a character is a vowel and a tuple that is returned at the end. And, don't ask ChatGPT. So asking ChatGPT doesn't count as trying yourself because your brain needs to work out. So this is basically what the solution looks like. So you're keeping track of how many vowels you have read so far, and you're also keeping track of how many consonants you have read so far. So how do we know whether something is a vowel or not? We have a list of vowels that we have initially declared, and if a character is in this list, then we know that it's a vowel, and we simply increment that variable. And otherwise, if it's not a vowel, then we know that it's going to be a consonant. And once we're done with the loop, we have scanned all of the characters in the string. Then what we do, we create a tuple and we pack two values in it. So one is the number of vowels and the second is the number of consonants, and then we return the tuple as a single object. So here's the example usage. So it's going to basically return a tuple with two vowels, which is E and O, and then three consonants, which is H, L, L. And same goes for the other example. So if we run this code, and that's exactly what you see on the screen. Okay, let's talk about lists. What are lists? So essentially, lists are also indexable ordered sequences, just like tuples. Usually, lists are homogeneous. It means that ideally you should put all integers or all strings, but Python does not enforce that. You can mix types if you want. The key difference from tuples, first, the lists use square brackets, tuples use parentheses. And the other important distinction is, and this is the big one actually, that lists are mutable. You can change individual elements after you create the list. If tuples are a sent WhatsApp message, lists are a Google Doc. Anyone with access can edit them. Let's put them side by side. Tuples on the left, lists on the right. Both show their syntax. So you use parentheses with tuples in order to create them, and you use square brackets with lists in order to create them. But in order to index items, you use square brackets with both of them. And that square brackets is also used with the strings. So again, to reiterate, T equals parentheses 1 to 3, that creates a tuple, and L equals square brackets 1 to 3, that creates a list. Tuples are immutable, they're faster, they consume less memory, whereas lists are mutable, but they're much more flexible and they have a dynamic size. They're not fixed. If you try to change the first item of the tuple, for example, in this case, the item which is at index number 0, you'll get an error, just like a string. But in a list, you can definitely change the first item to 5, for example, and that works perfectly fine. And when you run this statement here, your new list is going to update the value and it's going to show 5 to 3 instead of 1 to 3. So you can choose between them based on whether you need to change the data later or not. So here is a quick exercise again. You need to write a function called sum and prod. It takes a list of numbers. It returns a tuple. So the first element is going to be the sum. So basically, we are now explaining the return value of what it needs to return. You have a list of numbers. The first element of the tuple that you need to return is going to be the sum. The second product is going to be the product of all numbers. So what's happening here? The input is a list and output is a tuple. You combining both types together. So pause the video and give it a shot. See you in a few seconds. All right, so this is what the solution looks like. There's nothing new here. We're just adding all the numbers and we are multiplying the numbers in a given list. The new thing here is that once we have the total and once we have the product, we are creating a new tuple based on these two values, and then we are returning this tuple as a 2-value pair. And when you run the code, That's exactly what you see as a two-value pair tuple in these call expressions. So now let's walk through a basic list of operations. An empty list is just empty brackets. So this is a list that contains 0 elements. L equals square brackets 2 comma a comma 4. And here you can see that it contains another list as a fourth item. And then length of L gives you the number of items that are in L. So again, be careful that this list L does not contain 5 elements. It contains 4 elements because the fourth one is a list. It's not 2 elements. It's just one entire object that's counted. L of 0, that's the first item that gives you 2. L of 3 gives an entire list because that's what it is that's stored at that position. You can add 2 lists using a plus operator. So basically, when you add 2 lists, it's going to give you another list with all of its elements combined together in a larger list. So it's going to be 2 and a and 5 and 6. You can also apply a function called max on a list, and it's going to give you the maximum value. And you can also apply min. And like strings, you can slice lists exactly like strings. So for example, this is going to evaluate to a and 4. Why? Because you start from 1 and the item at 1 is a, and then you include 2, and then you go up till 2, not including 3, which is 4. So the next item at index 2 is 4. You can also loop through a list with for loop for E and L. This works exactly like a string. So if you run this piece of for loop here, it's going to print all of the individual items from this list. And here's the key difference from tuples. If you want to change the item that's at index number 3, you just say L square brackets and put the index number that you want to change. And then you assign it the value that you want to change it with. For example, in this case, we want to update it with 10, and that actually works. It changes the list. So you can see the blue box here, and that basically highlights the mutation. And here's a visual. L equals square brackets 10, 20, 30, 40, 50. That's going to create a new list. And positive indices go 0 through 4. Negative indices go -5, -1 through -5 in the opposite direction, just like the strings. Now, positive indices, they work exactly like strings. So index number 0 is going to give you the first item that's at position 0, and L4 is going to give you the item that is at position number index number 4. And similarly, the negative indices work the same way. L -1 is going to give you the last item that's at the end of the list, and so on. What about slicing? L, if sliced from 1 to 4, gives you 20, 30, and 40. And it does not give you 50 because 4 is not included here. It starts at index 1 as goes up to, but not including index 4. And it returns a brand new list. So slicing always returns a brand new list. Now, this is the same slicing that you learned with the strings, actually, and the same rules and the same behavior. All right, so this one is a little bit tricky. Look carefully. We start with L1 equals list with one item, RE, that's a string. And L2 similarly is a single string, one item in this list. And then L3 also has one item. That's a single string in this list. Now, L1 and L2, as we have already seen, that the plus operator is going to combine 2 lists and create a new list and then return that. So L4 is going to be a concatenation of L1 and L2. And that's going to be a new list that contains RE and MI and MI2 items. Actually, you can pause the video and then you can try running this code on Tawny or whatever IDE that you prefer, and see what output it gives you. Here, this append function, basically L3.append L4. This is going to add L4 as a single element to L3. So L3 becomes, DO, a string, comma, and then the entire L4 list, that's a combination of L1 and L2. So then L3 is going to come to contain two items. So basically what append does, it just adds a single item to the list at the end of the list. So append always add item to the end of the list. So again, pause this video and work out what L1, L2, and L3 and also L are at the end when you run this code. This brings us to a very important concept. Some functions mutate the list and they don't return anything useful. So they basically return none. We call this a side effect. The function doesn't give you a new value. Instead, it changes something that already exists. Append is a side effect function. It changes the list in place and returns nothing. So when you write L equals L1 dot append L4, L3, append does not return anything, but it is going to change L1. Let's look at append more carefully, starting with L equals, a list of 3 items, 2, 1, and 3 in this order. So order matters in lists. When we call L dot append a value of 5, the 5 slides into the list at the end. So L is now 2135. The new item is at the end, as you can see, and the list is muted. The list has changed, essentially. Now, look at the syntax here very closely. L dot append 5. So what is that dot here? The lists are Python objects, and append is a method that belongs to the list object. In Python, everything is an object. Objects have data, objects have operations, and you can access those operations using the dot, basically. All right, track this time. Write a make ordered list function. It takes a positive integer, so this n is an integer, basically, and it's positive. And it returns a list of all integers from 0 to n, including n. So pause the video and try it out, give it a shot. Basically, what you need is an empty list, a loop, and the append function that we just seen. See you after a few seconds with the solution. All right, there are multiple solutions to this problem. Here's the first one. We start with an empty list, as you can see in this line, and then loop from 0 to n using range. And then we go up till n plus 1. And, pause the video and think about why do we need to go n plus 1? Why not n? And then you append each value to the list one by one. So basically, this is going to add a single value at the end of this list. And this list will be mutated. This is a mutator function. And you keep on doing that. And at the end, you simply return the entire list. That's pretty straightforward and it works perfectly. And when you call this function with the value 5, it's going to return a list that contains 0, 1 to 3 up till and including the last value 5. There is a shorter way. Return list of range, n plus 1. So basically what we are doing here is this range, as we have seen in our loops lecture, is going to give us values from 0 up till n. And then this is not a list yet, but we need to explicitly convert this into a list using this predefined keyword called list. And then that is going to formally convert that into a list, and then it's going to return that. So this entire one-liner has the same effect as the previous code that we saw in the previous slide. So both solutions are correct. The second one is more Pythonic. It uses Python's built-in tools. All right, next exercise. Write a function, remove element. So basically, you're given a list that is being passed as a parameter, and then you're given an element that is being passed as a parameter. What you need to do is you need to create a new list, and then you need to return that new list. That list has all the elements of L except those that are equal to E. So for example, this is a list. And if we want to remove element 2 from the list, this function is going to return a new list. It's not going to change the previous one. So it's going to return the new list with all of the elements 2 removed from it. So it naturally returns 1, and all of the 2s are removed here. So again, to reiterate, you are returning a new list. You're not modifying the original list. So pause it and give it a shot. And we go to the solution in a couple of seconds. All right, let's take a look at the solution here. So first of all, create an empty list called a new list, and then you loop through L, item by item, one item at a time. And if that item is not equal to our target element, then we simply append that item to the list. So if that is equal to our target, then we do not append that item to the list. So that is going to result in all of the items removed from the new list. And then we simply return the new list as the return value. And that's about it. That's pretty simple. And if we run this code on this list and the value, then it's going to print 1 and 3 with 2 removed. So I encourage you to type this code on your favorite, IDE or Tony, and test with various values, different values, both for list and for these elements. So this is basically a very common pattern. Build a new list by filtering elements from an existing one. You'll see this this pattern over and over again. Now let's convert between strings and lists. And yes, you can do that. This is very useful for text processing. Well, at first, calling a list on a string converts it into a list of characters. So a list of hello gives you H, E, L, L, and O. Second, calling a split on a string breaks it into a list of words. By default, it splits on a space, but you can also split on other characters if you like. So here, for example, you can also pass a character. For example, s.split, comma, is going to split on the entire sentence on commas. Let's take a look at this visually. We start with s equals hello world from Python. That's an entire string. And the words are separated by spaces. When we call words equals s.split, Python chops the string at every space. So you see these arrows, each word gets pulled into its own box. Hello world from Python. So the result is going to be another list with these words as an individual items of that list. So this list is going to contain 4 items with these 4 words as strings. Now the spaces did completely disappear. They were just separators. What about the other direction? You have a list of strings and you want to combine them into one string. Here we use the join syntax. The join the syntax is basically space, or it's not a space, it's just a double quotes. It's an empty string dot join and then L, that's a list. So the string before the dot is the separator. And if you do not want to have any separator between the items in a list, the strings in this actually, this list that the joins act on is a list of strings. It cannot have any other data type apart from strings. It must have all strings in this list. So the separator here in this case is an empty list. And you can use any character as a glue, basically. Here's an example join in action. L equals a string, basically, which contains 3 items, and those items are strictly strings. You cannot have other types of items if you want join to work on a list. So when you say result equals to a space. This is not an empty string. This is a space basically, dot join L. We are joining with a space character. You see the plus signs here and the spaces in between each word. So that's join at work. It inserts the separator, and the separator in our case is this space here between every pair of words. So the resulting string is going to be hello world from Python. Split breaks the string into a list. Join reassembles the list into a string. So that's the reverse operation. Practice time. You have to write a function called count words. It takes a sentence. It returns how many words are in it. And that should be really trivial to do at this point. Previous slide is like it contains the answer. So pause this video, and I encourage that you do not look at the previous slide right now. Try it on your own, and then wait for the solution in the next slide in a few seconds. But did you get it? Words equal our sentence sen dot split. So that splits into multiple individual words, and then it creates a list out of that words. So since we have a list, we can measure the length of how many items or how many words are there in the list, and then we can simply return its length at that point. Like, as an example, it's going to return hi and its, and then me, 3 words in a list, and then you can simply count its length and then return 3. That's it. 2 lines of code. Split does the heavy lifting, and the length counts the pieces, the number of pieces that are in the returned array. If your solution was longer than 2 lines, you're working too hard. Python already has the tools. You just use them. A few more list operations. We have seen append. It adds items to the end, and it also changes the list. It mutates the list. Here's another new one, sort. L.sort sorts the list in place, meaning that it mutates the list. It changes the list, and it returns none. It returns nothing. Reverses the list in place. It's also a mutation. It returns nothing. But sorted, it does sort, but it returns a new list, a new sorted list. Basically, it leaves the original list L unchanged. There is absolutely zero mutation here. There is no mutation. So here's the pattern. Methods with a dot like L.sort tend to mutate. Built-in functions like sorted L, they tend to create new objects. So that's a general behavior in Python. Now let's combine what you have learned, right? Sort words function. So basically what it does is it takes a sentence and it returns a new list of words that are sorted alphabetically. So for example, if sort words took a sentence called look at this photograph, then it should return at look photograph and this in increasing sorted order. Pause this video and see if you can do that. So the hint is that you first need to break the sentence into pieces, and then you sort those pieces in order. All right, so this is a solution. Words equals sentence dot split. So this returns the list of all individual words broken into pieces and stored in a list. And then when you do sorted, apply function sorted on the list words, it's going to sort. It's going to create a new list, and it's going to sort the words and then return that. It's not going to change the original list, basically. And remember that sort returns none. So at this point, if you wrote words dot sort, then you return none. Be very careful. Here is another big idea. Functions with side effects can mutate their inputs. If you pass a list in a function and that function changes the list, the changes are visible outside the function. The caller's list gets modified. This could be very, very powerful, but it could be also very, very dangerous if you're not careful. Let's trace this carefully. We have double elements as a function. It takes a list, and what it does is it just doubles every element in this list, and then it updates its previous position. Now what's happening here, first the function definition is stored in the global frame, and now the numbers equal 1, 2, 3. We're creating a new list of these 3 items. So this creates a list object in the global frame. Now, when we call double elements with the parameter numbers, a new frame opens, and in that frame, LST, that's the parameter, is bound to the same list object as numbers. So you see the red arrow here. Both names point to the same box in the memory. And then the function runs the loop. It mutates each element, doubling its value. And the list becomes 2, 4, and 6 after being doubled. And the function frame is destroyed. Because when a function exits, its frame is destroyed. But the important thing to note here is that the mutation is persistent. And even after the function, if you print the original numbers list, then you will see that it has been modified to new values, 2, 4, and 6. So why is that? Because numbers still point to the same object, and print numbers give us 2, 4, and 6. So, it's kind of like lending your notebook to a friend. They write in it and they hand it back. Now, your notebook has their notes too. Same notebook, that's not a copy. All right, your turn. You have to write a function called square list. So basically what it does is it mutates the list L by squaring each element. And it should return none. It should return nothing. And the mutation is the whole point here in this case. So after calling square list on the list 1, 2, 3, 4, the list should become 1, 4, 9, and 16, the square of all these numbers. So pause this video and give it a try and come back after a couple of seconds. And the hint is that you have to iterate over the list of items and make sure that you actually mutate or modify this list, which is being passed as a parameter, not create a new list. All right, so here is the solution. For I in range, how many number of items there are in the list, and then L of I equals to, you read L of I, basically what this line is saying, that you read item from a position, you square it, and then you store it at the same position. That's what it's saying, and that's it. We use a range of length L to iterate by index, and we do not use for E in L. Why is that? Because we need to modify each element in its position. Changing E would just change the loop variable, not the actual list. So we cannot use that in syntax here. You must use the range if you want to modify at a particular index. As you can see that this function doesn't have any return step, and the function just mutates L directly. And that's exactly what you see in this print statement here. So the original list is modified and the new values are 1, 4, 9, and 16. All right, now some tricky cases. These really test your understanding of lists. First, a note about range. When you write for I in range L, the range object is created once at the start of the loop. So it just behaves like a tuple, and it has a fixed set of values. It gives you the first element, and then the next element, and then the next element, and so on. Here is an example of range. If you go to your Tony interpreter, and let me just clear this up. And if you type here range, just the function range, let's say 4. And then as you can see that it returned something really weird, because what it returned is not a list. It's a kind of an intermediary representation of a list, which you cannot use directly, but it contains numbers from 0 up till 3. So if we explicitly convert this into a list by using the list function, then you'll see that now that's a reusable list. So the for loop is able to use this intermediate representation, but we cannot use it directly unless we convert it into a list first. So range 4 gives us an intermediate representation, a kind of an intermediate tuple, which we cannot directly use. And that's going to be 0, 1, 2, and 3. And similarly, range 2, 9, and 2 is going to give us an intermediate unusable, directly unusable tuple. That's going to be 2, 4, 6, and 8. What happens here? L equals 1, 2, 3, and 4. So that's a list. And then for I in range length of L dot append I. So you're adding items in the list one by one. Now range of length L creates an intermediate tuple with 4 items, 0, 1, 2, and 3 that we have already seen. And it's a fixed syntax. It's a fixed sequence. It doesn't change. Now for the first iteration, the value of I is 0. When you append I to existing L, it's going to add the value. This append is going to add the value at the end of the list. So the list, new list, is going to become 1, 2, 3, 4, and 0. And in the second iteration, the value of I becomes 1, and that 1 is appended again at the end of that list. And then what happens is when I is 2, you append that into the list. And then when I is 3, one more is appended. And that's pretty much it. That's the end of iteration. The loop stops. The range only had 4 values. Mutating L does not affect this range indicator. So this is, again, a very important point. When you run this loop for the first time in the first iteration, this range object, this intermediate representation of this tuple, is created only once in the beginning. And then this is referenced throughout the loop when it's iterating. And this range is fixed. So even though it would appear that the length of L is changing every single iteration, but actually under the hood, it's not. That's the key takeaway of this slide. Now watch what happens when we change the loop. This time we iterate over L directly. We are not iterating over a range. So there's a very important difference as compared to the previous slide. Now, first iteration, E is 1. We append I, and the list grows. Second iteration, E moves to 2, and we append I again, and the list grows again. And then E goes to the third, and then E goes to the fourth. Basically, L keeps getting longer and longer. So the loop keeps finding new elements. That's the key point. Because we keep appending the list. Even the appended elements have newer elements after them, because the append function is going to add items at the end of the list. So this loop never stops. It's an infinite loop. And you can pause the video, you can type this into Python interpreter or Tony, and then you can try it out. It's kind of like standing in some government office line. Every time someone gets served, 2 more join in the queue. You're never getting out. Here's the lesson. Iterating over a range is safe and the range is fixed. But iterating directly over a list while it's mutating, it's very dangerous. Now let's combine lists. The plus operator concatenates. L1 is 2, 1, 3, and L2 is 4, 5, and 6. The plus operator is going to take elements from both lists, and then L3 equals L1 plus L2. So this means that it's going to give us a new string with all of the items from L1 and all of the items from L2, flat presented in the list L3. So the list L3 is going to be 2, 1, 3. That's from L1, and then 4, 5, 6. That's from L2. So this list L3 will have 6 items in it. And also note that L1 and L2 are completely unchanged. They do not change. They do not mutate under the plus operator. But extend is a completely different story. L1.extend 06, that's a list, basically contains 2 items. So that's going to mutate L1. So as you saw in some previous slide, that we talked about a general rule that pretty much all the functions that you invoke using the dot that mutate the object. So in this case, since you're invoking this method on this object L1 list, so it's going to mutate the list. So our L1 changes to 213, and then you add 06 at the end. So again, it combines 2 lists, but in this case, it mutates the existing list. That's a visual representation of what we've just talked about with the extend. So take a look at this in a important detail. Extend adds elements from the list to pass in. It doesn't pass the list itself. So what do we mean by that? It means that this list contains 2 items, a list and another list. So when you extend, these 2 items will be added to L2, just like so, as an individual elements. So L2 becomes 4, 5, 6, and then a list 1, 2, and then a list 3, 4. So the total number of items that L2 has is 5. And compare that to append. So if you append, that's going to append to 4, 5, 6, and then this entire thing at the end. And in that case, the total number of items is going to be 4, not 5. So you can simply try it out in Python interpreter and see what happens when you try to append this instead of doing extend. And pause the video, do it, and then we come back in a couple of seconds. So you can think of extend as unpacking a suitcase. Each item goes in separately, and append just throws the entire suitcase in. Okay, this is the last tricky example. L equals 1, 2, 3, 4. And then for E in L, L equals L plus L. So you might think that this is another infinite loop example. Well, for your utter surprise, it's not. And actually, before proceeding, you can pause the video, type this example in the Python interpreter, and see what it outputs, and then come back. So we resume in a couple of seconds. All right, so what's happening here is in the first iteration, E is 1, L equals L plus L. So remember that this plus operator is going to create a new list, and it's going to return that back into L. So the L is going to be bound to the new list that the plus operator creates. And in the second iteration, E is 2, L doubles again to 16 elements. And third iteration, E is 3. And then in the fourth iteration, E is 4, and the loop stops, essentially. And it runs exactly 4 times. And why? Because L equals L plus L, this line here that you see, this is a reassignment. It's not a mutation. It creates a brand new list and points L to it. But for the loops iterator, it's still walking through the original list that's in the memory that it originally pointed to, that you see here. And the original had 4 elements, so the loop runs exactly 4 times. So this brings us to a deeper concept, the object identity. How do we know that if 2 variables point to the same object? You can call L.clear to remove all elements from the list, but that doesn't create a new list. It's the same object. It's just empty. And then you have ID. Python gives us the ID function. It returns a unique identifier for each object in the memory. Same ID means it's exactly the same object. So now let's compare. On top, it's mutation. L equals 1, 2, 3, and it has an ID 1, 2, 3, 4, 5. Then we do L dot append. We append a new item in the list. What happens is L is now 1, 2, 3, 4, but the ID is exactly the same as previous. So it's exactly the same object modified. Now a reassignment. Again, for the sake of example, let's say that we have a list with items 1, 2, 3, and it has an ID 1, 2, 3, 4, 5. And when we do reassign at a new list, 5 and 6, now L points to a completely new list with a completely different ID. Let's say for the sake of example, again, 67890. And that's different ID means that's a different object. The old list is grayed out. Nothing points to it. And the Python's garbage collector will clean it up soon. So this distinction, mutation versus reassignment, is crucial for understanding objects in Python. Let's do a quick little demo for ID. So again, let's say you have a list, L equals to 1, 2, 3. And when you do ID of L, you get this long random number. And when we do L dot clear, and when we check the contents of L, and then you see that it's completely empty. But if we check the ID, it's exactly the same as previous. We type when we previously checked this ID. So it means that this was exactly the same object, but now it's empty. It's mutated. But when we do L equals to, let's say, 5 and 6, so that points to a new list. And when we do ID, this time, it's going to give us a completely different number. So which means that this L now is reassigned to a completely different object in a separate position in the memory. Try this in your Python console, 2 columns of code here. On the left side, append and clear, those are mutations. And on the right side, and then on the right, append and then reassign to an empty list. So check the ID of L after each step. And on the left, the ID stays the same object. And on the right, the ID changes after reassignment. So that's a new object, completely different object. So pause the video and type this out, seeing the actual ID numbers that makes this concept click. All right, time to wrap up. Tuples, immutable sequences created with parentheses. These are great for returning multiple values. They can't be changed once they're created. And lists are mutable sequences. They're created with square brackets, methods like append, sort, and reverse mutate the list in place. And we also saw split and join for converting between strings and lists. And we saw how functions can mutate lists through side effects. The big ideas today: mutation versus creating new objects, side effects, password reference, and object identity. And that's a wrap for lecture 11. Lists will be with you for the rest of this course and honestly, the rest of your programming career. Make sure you understand mutation, you understand side effects and the difference between creating new lists and modifying the existing ones. Practice the U-try exercises if you haven't already. They're not a busy work, but they're exactly what shows up on quizzes and exams. And remember that if you're confused about whether something mutates or creates a new list, then check its ID, or better yet, check the slides and the course material, or even better, just shoot a message on Discord. So see you next time. Bye-bye.